What happens after century-old trees come crashing to the forest floor? Today, join RaWMachines as we uncover the remarkable journey hidden behind the life cycle of old-growth timber. From the decisive cuts made deep in the forest, to the advanced sensor-driven systems of Idaho, and finally to a traditional Swiss sawmill where human intuition still outperforms artificial intelligence. From the wilderness to the factory floor, every step of the process will be revealed. It all begins in the vast forests of the Pacific Northwest. Here, our logger is performing a technique that demands absolute precision. Watch until the end and see if you can guess what it is. To control the direction of the fall, he first makes a V-shaped notch on the front side of the tree. This cut acts like a hinge, guiding the tree to fall precisely in the intended direction. The same process is repeated on multiple trees positioned along the planned felling line. However, the logger intentionally leaves a portion of the hinge wood intact on each tree to maintain control over its movement. The key lies in what is known as the trigger tree. This is the tree located at the highest point on the slope. Once the back cut reaches roughly 3/4 of the way through the trunk, the tree's center of gravity shifts and it begins to fall. Almost instantly, its momentum is transferred to the second tree, then the third, and the others that follow. The result is a remarkable display. 4 or 5 towering trees come crashing down within seconds, creating a powerful chain reaction that shakes the ground. But felling the trees is only the first step in a much larger production chain. Soon afterward, specialized logging trucks begin transporting the timber out of the forest. These massive vehicles are designed to haul dozens of tons of logs across rugged and challenging terrain. Convoy after convoy rolls onward, carrying tree trunks from their natural environment to modern industrial facilities. Their destination is the Idaho Forest Group mill in Lewiston. Even from the outside, the scale of the facility is striking. Vast log yards stretch as far as the eye can see. Trucks move in and out continuously. The sound of engines, the hum of machinery, and the scent of freshly cut wood combine to create the distinctive atmosphere of one of the largest wood processing facilities in North America. The log yard is the first gateway into the production process. In the past, sawyers relied on visual inspection of the bark, the feel of the grain, and even the sound produced by a light tap to assess the quality of a log. Today, that work is supported by an extensive network of sensors. Each log passes through a system of electronic scales, optical sensors, and 3D laser scanners. The system not only measures length and diameter, but also identifies natural curvature, the location of knots, and potential internal cracks within the tree trunk. Once the log is fully profiled, its journey inside the mill officially begins. The timber is fed directly into a rotary ring debarker. High-strength carbide cutting tools spin rapidly around the log, gliding effortlessly like a colossal apple peeler. The automated system dynamically self-adjusts its tool pressure, ensuring the knives cut exactly to the required depth to strip away the bark without ever scoring or damaging the valuable log core inside. Once the log is stripped clean, it is fed directly into the head rig, the undisputed heart of the entire mill. Here, a massive efficiency breakthrough takes place through advanced curved sawing technology. Instead of forcing a naturally swept log through an artificial, perfectly straight cutting path, the saw blades shift dynamically to follow the natural contour of the timber. While it sounds simple, this critical engineering adjustment significantly maximizes fiber recovery rates. Furthermore, these modern saw blades feature an ultra-thin kerf profile. The cutting gap they produce is roughly half the width of older, legacy systems. This technical edge means far less wood is wasted as sawdust, leaving more premium material to be turned into high-value products. Each pass executes in a fraction of a second, driven by thousands of continuous background calculations, running simultaneously to ensure peak operational yield. After the primary cut, the squared timber sections, cants, continue through a series of gang saws, where they are further processed into smaller boards and lumber products. Every movement in this stage is closely monitored to ensure compliance with strict production standards. If sawing timber is a demonstration of industrial power, then the utilization of byproducts is a reflection of modern industry at its most intelligent. IFG does not simply produce lumber. It operates a circular ecosystem in which the life of the forest is renewed through even the smallest products it creates. After completing the primary sawing operations, the lumber is still not ready to be shipped. It retains rough edges, the natural curvature of the original log, and various imperfections that developed during the tree's growth. The next stage is edging. Here, high-speed saws remove the uneven outer edges, creating straight, clean, and uniform sides. Immediately afterward, the trimming system takes over. Rather than relying on human judgment alone, high-resolution cameras scan the surface of each board, instantly identifying defects or flawed sections at either end. Precise cuts are then made automatically, ensuring that every piece of lumber leaving the production line meets the highest standards of quality before entering the most rigorous inspection stage. At IFG, modern technology does not replace the role of people. Instead, it enhances and celebrates the value of human expertise. Lumber is graded into several categories, including select, construction, and standard. Although automated systems perform most of the measurements and evaluations, experienced inspectors still examine each board by hand. Accuracy here is not defined solely by data and numbers. It also relies on professional judgment developed through years of experience. It is a seamless blend of traditional craftsmanship and advanced automation. The wood now has its shape, but it is not yet ripe. Inside, the moisture content is still high. If left untreated, the wood will warp, crack, or even decay over time. Therefore, the wood must undergo the drying phase. Depending on the species and thickness, this process lasts from a few days to several weeks. Each stage is pre-programmed. The heat is increased slowly, held at the peak, and then lowered under control to prevent thermal shock. From a natural moisture content of about 50%, the wood is reduced to 15 to 19%, the ideal stable level for construction and furniture. If you listen closely in the drying chamber, you will hear the wood breathing, a very faint crackling sound as the wood fibers contract. The workers call this the sound of the wood maturing. When the chamber door opens, white steam billows out. The wood is lighter, more stable, and ready for the planing step. In the planing mill, cutter heads spin at speeds exceeding 10,000 revolutions per minute. They shave away layers of wood no thicker than a strand of hair, yet that is enough to transform a rough surface into one that feels smooth as silk. The lumber is then automatically sorted, stacked, and bundled into large units. Steel straps secure each bundle, while barcodes and traceability labels are attached to ensure full product tracking. Every bundle of lumber now carries its own production record. Manufacturers can trace where it was processed, which raw material batch it came from, and every stage it passed through before reaching the customer. From Idaho, these products are shipped around the world, from construction sites across the United States to factories and development projects in Japan, Germany, Australia, and many other countries. In another corner of the mill, even the smallest particles have value. Sawdust is compressed into biomass pellets, a clean-burning fuel that serves as an alternative to coal. Wood chips are sent to paper mills or particle board manufacturers. Tree bark is repurposed as landscaping mulch for residential areas, while planer shavings are recycled into fiberboard and other engineered wood products. The mill's energy system is powered in part by its own production byproducts, creating a highly efficient closed-loop cycle in which wood helps sustain the very process that transforms and renews it. Once pine and spruce trees standing tall in the forests of Idaho, they are now entering a new chapter in their journey. Through a combination of natural resources, skilled craftsmanship, and precision technology, they are transformed into essential materials that help build and sustain modern cities. But while Idaho's timber industry is defined by scale, speed, and technological power, a very different philosophy can be found across the Atlantic. It is a philosophy rooted in patience, precision, and a deep respect for the relationship between people and the forest. Our next stop takes us to Switzerland, home to August Breuweiler AG. Here, we will discover a distinctly different approach to forestry and wood processing, one shaped as much by tradition as by innovation. The scale of this facility may not rival industry giants like IFG, but it embodies what many industrial engineers consider the gold standard of modern craftsmanship. This is not a mass production operation. Every order is planned and processed individually, often for highly specialized projects, luxury timber homes, handcrafted furniture, or architectural components that require precision measured down to thousandths of a millimeter. One, the log yard. The journey at August Breuweiler begins with a grading process based on criteria that even advanced AI algorithms struggle to truly comprehend: wood species, origin, age, and most importantly, the harvesting season. The Swiss firmly believe that timber harvested during the winter, when the sap stops flowing and the cellular structure is at its most stable, yields unparalleled durability. This specialized wood is highly resistant to warping, possesses natural pest resistance, and retains the clean, serene characteristics of the high Alps. Two, debarking. The machinery at Breweiler is as modern as any top-tier facility in Europe. However, unlike IFG, where automated sensors operate autonomously, the technology here serves strictly to support human intuition. The debarking system utilizes micro-cutting heads programmed to prevent any surface scarring. Every minor deviation, even a matter of a few millimeters, is immediately detected and manually corrected by expert operators. Three, sawing and breakdown. The sawing phase is where the true, latent value of each unique log begins to reveal itself. Instead of prioritizing maximum throughput speed, the mill utilizes bandsaw systems capable of executing ultra-precise cuts with minimal material kerf loss. These thin-gauge blades drastically reduce the volume of wood lost to sawdust, maximizing the yield of premium fiber from the core of the log. Throughout the cutting process, the sawyer continuously monitors grain direction, knot placements, and the natural characteristics of the raw material. The objective extends far beyond sheer volume. It is about unlocking the exact potential of each log. Certain trunks are designated for heavy-duty structural components in construction, while others are earmarked for fine furniture or high-end architectural applications. Every single breakdown decision is guided by a profound, generational understanding of the material, a level of craftsmanship that algorithms cannot fully replicate. After the sawing process is complete, the timber moves on to the drying stage. Unlike the industrial kiln drying systems commonly used in North America, Breweiler continues to preserve the tradition of natural air drying. The boards are carefully stacked into large bundles inside well-ventilated storage sheds, sheltered beneath sloped copper roofs that protect them from harsh sunlight while allowing mountain air to circulate freely throughout the year. This stage lasts for several months, and in some cases as long as half a year. The wood dries slowly and evenly, resulting in greater stability while preserving its natural color, distinctive aroma, and cellular structure. Inside the workshop, craftsmen still rely on familiar practices that have been passed down through generations. They run their hands across the surface of the wood to feel its texture, tap it lightly to listen to its resonance, and even detect traces of remaining sap by its scent. These are not random habits, but expressions of professional knowledge refined over decades of experience. Technology plays an important role in the process, yet the spirit of craftsmanship remains present in every stage of production. If Idaho Forest Group represents efficiency, scale, and the power of artificial intelligence, then August Breweiler AG stands as a testament to the enduring value of human skill. Two methods, two rhythms of work, and two distinct cultures, yet both share the same philosophy: to respect wood and to make use of it through understanding rather than exploitation. From the very moment those ancient giants shudder and fall amidst the expansive forests of the Pacific Northwest, to the final shipment of packed lumber bound for global markets, we have witnessed one of the most complex and breathtaking material transformations in modern industry. Behind every seemingly ordinary board lies an extensive journey spanning multiple production phases, generations of technology, and thousands of decisions executed with absolute, pinpoint precision. In Idaho, we see the sheer power of industrial scale. Massive manufacturing complexes operate like living organisms, where every data point is captured, analyzed, and instantly converted into peak efficiency. Each cut is mathematically optimized to minimize kerf waste. Every single byproduct is aggressively reclaimed, and virtually no part of the tree is allowed to go to waste. It stands as a profound testament to technology's ability to maximize the yield of our natural resources like never before. Yet, across the Atlantic in Switzerland, we encounter an entirely different philosophy. Rather than chasing raw speed and massive throughput, the craftsmen at August Breweiler AG choose patience, rigorous precision, and an intimate understanding of the material. Here, technology never seeks to replace the human element. Instead, it serves as a supporting tool for the hands-on experience, instinct, and occupational wisdom accumulated over generations. The striking contrast between Idaho Forest Group and August Breweiler AG reveals a compelling truth. There is no single blueprint for producing premium lumber. Though worlds apart in their methods, tempo, and cultural backdrop, both operations converge on the exact same core mission: unlocking the true value of wood through a deep comprehension of and profound respect for a material that nature took decades or even centuries to create. Ultimately, the most incredible aspect of this entire journey does not lie within the colossal machinery, the hypervelocity saw blades, or the cutting-edge artificial intelligence systems. It lies in how humanity has mastered working alongside nature to breathe a second life into the timber. Within every finished product, the distinct footprint of the original forest remains intact, a lasting reminder that behind each perfected piece of wood is a long timeline of time, engineering, labor, and human ingenuity. Thank you for watching until the very end of our story. If you love deep dives into these industrial journeys, please hit like, share, and subscribe to the channel so you never miss our upcoming features. This is RaWMachines, signing off. Thank you, and see you next time.